You can type them in chat. You can open your mic and ask. Either way.
Not putting like any pressure on you or anything, but when do you
Hmm.
think you'll have the lab reports graded?
I don't know. I still have about half to do. They take a long time, and it's weird. It's the first time I ever graded them online,
Uh-huh.
and in some ways I like it, in some ways I don't. And so I don't know. I'll try to get them out. If this was normal school, I'd have them out by Thursday. I would have published them Thursday. So maybe I can get there. We'll see.
Okay, thank you.
Like that answer, if this was regular school. Oh.
I have a question about venoconstriction and dilation.
Mhm.
It said that it just seems like it would in my mind it seems like it's reversed where constriction it says increases venous return and then dilation increases blood storage. Can you just kind of go over like an explanation for why?
Okay, so think back to anatomy and when you studied the blood vessels in histology, and the way to tell the difference between an artery and a vein was on the slide. Arteries were very circular, right? And they had a lot of, you could tell they had muscle layers and elastic and things like that. But if you looked at the veins, veins were all kind of scrunched down. It's because they're not very rigid, right? They don't have a whole lot of muscular siding like an artery does. So it's sort of like taking a bad knife and cutting crusty bread versus soft bread, and the soft bread gets all squished. So veins are really floppy. And because of their floppiness, that's why we store what, 60, 50, 60, 70% sometimes of our blood in the veins. It's because they have what they call high capacitance. They are really floppy, so they expand and accept blood. So when you do venoconstriction, you're not really constricting the lumen and increasing resistance. What you're doing is you're decreasing the floppiness and making it more rigid. If it's more rigid, blood has to return blood back to the heart because it just can't hang out in that floppiness of a vein. And so by venoconstriction, it it is opposite what you think for arteries, because arteries you would decrease the blood flow because you increased resistance. But for veins, because they're so floppy, all you do is you make them more rigid, and it basically gives blood a more direct route back to the heart by not having that floppiness. Does that make sense?
Got it. Yeah, that's much more clear. Thank you.
All right. What else? Any particular topics? Lab exam, lecture exam, since lab exam does start, what's today, Tuesday? Oh, tomorrow. Samantha, Alyssa, anything?
For the Starling's forces for the lab
Mm-hmm.
portion, do we just need to know how to calculate to use the formula and be able to calculate the net?
You should theoretically be able to answer all those questions on that sheet. There's like, I don't know, a dozen or so of them. So you should know like what has the highest pressure and why. Um, you should know what has the lowest pressure and why. You should know how to do the calculation. We won't, because it's in lab right now, we won't have to worry about it. But literally, when we start talking about the kidneys, the filtration of the kidneys takes place because of the Starling forces. And so we're going to go back and revisit that. So you should learn as much as you can about that, not just for lab, but it'll help you when we get to lecture. Um, the uh, most important things are what you mentioned. You should be able to calculate it. You should be able to figure out what a net filtration pressure is. That's the NFP. You should be able to tell me what end of the capillary is which. So there's a positive force at the beginning of the capillary, actually the first 2/3, that pushes fluid out. That's called filtration. And the last 1/3 of the capillary, it actually pulls fluid back in. That's called reabsorption. So the positive number, because of the equation, favors filtration, so that's the arterial end. And the negative number favors reabsorption, and that's the venous end. and you should be able to calculate that and figure out whether you got a positive or negative, and if you did, whether it's the artery side or the venous side and things like that.
So the determination of, you said like the positive side and the negative side comes after we calculate the net filtration pressure. So if it's
Yes.
positive, then it's arterial, and if it's negative, then it's venous.
Yes, perfect. Now you would expect that in a normal person, the arterial end would be positive of the capillary and the venous end of the capillary would be negative. So if I said in general, like a fill in the blank, we were at the arterial side of a capillary, would you expect a positive or negative net filtration number? You would say normally would expect a positive one. And that favors filtration, pushing fluid out, because there's more pressure in the capillary than outside. So we push fluid out.
Okay, got it.
I'm looking here at my notes, and it's like for the heart rate and the waves, it says like if the heart rate is 60 beats per minute, then you have like the RR interval, which is a second. Are we gonna need to like kind of have to know all these for like the lecture exam next week?
For the lecture, no, absolutely not. You just know that for the lecture, we talked about the ECG and what it is. So it's an electrical recording of the heart. In the lecture, we talked about, and we did this in lab too. So all this I'm going to say right now applies to lab, and I'll add in what you need to know for lab as well. But for the ECG, you know, it's an electrical recording of your heart activity. We can do it by putting electrodes like we did in lab for like the biofeedback lab. We measured heart rate through a property called volume conductance. And that's because we can stick electrodes on the legs and arms and still measure the heart activity. And volume conductance, basically what it says is that the electrical activity of the heart can be transmitted through your blood and interstitial fluid because of your electrolytes, right? So the ions dissolved, and especially, you know, sodium, potassium, calcium chloride, those ions that are dissolved in your body allow you to conduct electricity. So that's called volume conductance. For lecture, we didn't really talk about too much else in terms of knowing the patterns. You should be able to, like for lab, know the basic waves, the P, Q, R, S, T wave, what they correspond to for both lecture and lab. The P wave is atrial depolarization, the QRS complex we stick together, and that corresponds to ventricular depolarization and atrial repolarization. And then the T wave is the ventricles resetting, so that's ventricular repolarization. So you should understand that. Outside of that, you know, we didn't really talk too much else about it in terms of lecture. Now we connected like the P wave to the sinoatrial node, the SA node firing a little bit. And while it's connected to the conduction system and a few other things, I wasn't going to hold you responsible for that stuff because I didn't go into it in any detail in the video at all. And we wouldn't have done the same thing in lecture. I tried to repeat what we do in lecture if we were still doing our thing at school. In lab, you should understand a little more about the ECG. You should talk about heart rate changes with the ECG with inhalation and exhalation. You should understand heart rate changes with exercise. You should understand how we measure heart rate, and you just mentioned that a minute ago. With the R-DAR interval, we measure that distance. So that's because we're worried about the ventricles beating, and it's the QRS, that's ventricular depolarization, so that causes the ventricles to beat. And that's what ejects blood out of the heart and allows blood to circulate, so that's the most important phase of that whole thing. The other thing you should understand in terms of lab would be the QT versus TQ interval. Remember, the QT interval was from the peak of R to the end of T, and that's a measurement of ventricular systole. So remember, a contraction comes after the wave of depolarization, or at least delayed a little bit. And so if we wanted to measure systolic time, we'd measure what's called the QT interval. If we wanted to measure diastolic time when you're resting, we have the T to Q interval. That's called the diastolic time. And so one of the things in lab that we made a point of is at rest, let's say, you mentioned a heart rate of 60. If your heart rate was 60 or so, the average person would spend about 1/3 of the time in systole, which means that during contractions, about 1/3 of the cardiac cycle in total time. So if this was a 60 uh, heart rate at all, that means it would take 1 second for contraction, right? Because it would be once a second. And the contractile period would be about 0.33 seconds. So the QT interval from the peak of R to the end of T, if we measured it, would be somewhere close to about 0.33, 1/3, which means if you're not contracting, the only other thing you can do is relax as the heart. So that would be diastole. So measuring from the end of T to the peak of the next R wave, right, to complete the cycle, would be the diastolic time. And that would be about 0.67 seconds, or about 2/3. If you exercise, your heart went up to like 120, right, to make the math easy. Your heart rate, at 120 would be every half a second, right? So you'd beat twice a second. So your R to R interval time would be 0.5 seconds. But because of the change in the systolic and diastolic time, most people, would divide that up into about half a systole and now half a diastole. So it'd be 0.25 for systole. So the QT interval would be 0.25, and the TQ interval would be 0.25 as well. And if you kept on going like a heart rate of 180, it would actually switch the other way, and your systolic time would be 2/3 roughly, and your diastolic time would be 1/3. And the reason for that is you can't change systolic time too much, because physically it takes time to contract the heart. And so we can change appreciably diastolic time because we can change filling pressures and allow the heart to fill faster at higher pressure differences when you have exercise and things like that. And the consequence of that, the whole consequence of that talk was with QT and TQ interval is at rest, we measure mean arterial pressure as 1/3 systolic plus 2/3 diastolic because of that, right? What you really should do, right, is if you're exercising, you should probably measure it half and half, right? Just normal mean, because your heart spends 1/3 of the time in systole, at exercise, uh, half the time at systole and half the time at diastole. So that difference should be reflecting your heart rate. And if you really wanted to do it correctly, you probably should measure systolic and diastolic time and then use that to calculate mean arterial pressure. But my point being, we make this big deal about 1/3 and 2/3 for the calculation, yet that doesn't apply to all heart rates. So I know that was more than you asked, but that was everything I can think of at ECG stuff for lecture and lab.
Okay, thank you.
Also, and just to kind of finish that idea, I guess wasn't everything. We're measuring heart rate with the ECG during lab. We also looked at inhalation and exhalation, right? And just to be clear, it's pretty simple. Inhalation is an active process. It requires muscular movement. Your diaphragm has to contract. Your external costals have to contract. When you're doing that deep breathing, like we would have done in lab, the abdominal muscles, the rectus abdominis, the obliques also contract. Your scalenes contract, a couple other muscles too. But the bottom line is that because it's an active process, your heart rate goes up a little bit during inhalation. And then because passive largely relies on the elastic recoil of your muscles that help you breathe, that's a passive, primarily passive passive situation. And since it's passive, your heart rate actually goes down. So let's say if your normal heart rate was 60 again, during inhalation, we might see someone's heart rate go up to 70 or 80, especially with deep inhalation. And then with exhalation, it might go down into the 40s even. So it would go down with exhalation. That's because of the active passive things. So I think that's what we have to know about heart rate for lecture and lab and ECG. All right, what else? Any topics, lab, lecture, things you're curious about? Anything?
That's pretty much all I had to ask. Thank you.
All right. Alyssa, anything? Anything in the chat? Any general topic, lab, lecture? Michelle asked this before both of you were online, so I'll just repeat it while you're thinking. I'll give you a little more information. The lecture exam will be posted Monday morning. It will be 60 questions, multiple choice online, and then it'll have a take-home component, right? Take home in quotes, obviously, just like we did last time. Last time was 70-30. I went 60-40 this time. And the take-home portion will be available Monday morning, and you'll have to turn that in by Tuesday evening, 11:59. So you have 2 days basically to do it. The take-home is 4 10-point essays. And there are two that I didn't give you a choice for. There are two that I gave you a choice for. So the last two I think are either answer this one or that one, this one or that one. So I don't care which one, but they're all 10 points for a total of 40. So I'll give you your 100-point one. The online portion of the lecture exam, I want everybody to take sometime Monday because we would take that Monday in class. But because everybody's schedules could have changed with leaving school, I'm not requiring anybody to take it with their class at that time. So it's going to be available all day Monday from 8 a.m. to 11:59 p.m. I'm going to do the same thing with the lab quiz, which will start available at 8 a.m. tomorrow. And because of the Tuesday, Thursday morning class, I made it available till noon on Tuesday, right? So sometime between Wednesday morning at 8 and Tuesday morning at noon, basically, you have to take the lab quiz. The lab quiz seemed really hard to answer last time with calculations and things like that, showing your work online. And that seemed to take number of people commented. It took a long time to format. We didn't do Beer's Law that one, but how to do Beer's Law or something like that. So I made it mostly multiple choice. I think there's 22 multiple choice questions on your lab quiz, and there's just 2 short answer 2-point ones. So the 2 answers were impossible to move.
Each of those answers be, and then also would you be able to give an idea about like which section, so we can maybe start thinking about focusing more on those sections before we get those assignments or that assignment?
Are you telling me that you just want the questions earlier? Would it help you?
I'm just so I can like focus my studying, but because you said we had options, right? At least 2 of them we had the option to choose between one or the other.
Well, I like we've seen before for all of our exams, a great guide would be the group problems, right? In terms of looking at things. Now, when I did the group problem videos, I split them up into 2, and like last time, I sort of split them down the middle. And after I started the second one, I said, oh, I should have done 4 and 3 because I forgot I had like that bonus question that we wouldn't have done. But if you look at the group problems for the lecture, I have the 6 questions for class that we always do. And then I had a bonus one. And all 6 questions for class represented the cardiovascular system. And the first question was actually the first 3 questions was, how do we homeostatically regulate mean arterial pressure? What's the intrinsic and extrinsic mechanisms? And then number 1 was heart rate, and 2 was stroke volume, and 3 was TPR. And then 4 asked about the reflexes, the exercise pressure reflex and the baroreceptor reflex. 5 was some calculations having to do with cardiac patients, so similar to those examples that we saw that I posted about that some people hadn't seen yet, the cardiovascular physiology questions online in the lecture exam 3 section. And then the last one was talking about mean arterial pressure and trying to tie everything together. And so if you look at the group problems, there was only none of the 6 were on blood. So number 7 was basically, tell me everything you need about blood. So the idea was, don't forget about blood. So certainly in at least one of those questions, whether it's an option or a straight, hey, you should do this, you should know about blood. And certainly a lot of the multiple choice questions will be about blood. I didn't actually count how many of the 60 were blood and how many were cardiovascular, but I would think that there'd be a number of them on the blood, and for their blood in general and the characteristics and the functions of blood, and all the different things. We talk about red blood cells and the difference between the oxy and deoxy and carbamino and all those things for hemoglobin, and all the different things, a little bit about disorders and anemia type things, and having too many. Certainly I'll ask about blood production, right? Blood cell production. So the hemopoietic pluripotent stem cell and how it can become any cell, and the different, hormones, the chemicals that influence that, hematopoiesis, and so, erythropoietin and thrombopoietin and leukopoietin and the colony stimulating factors when you add in leukopoietin and those differences. You should understand the different types of white cells and what the subtypes are and what their functions are and how you identify them. For lecture, you put in their function and number. For lab, you just know the function, not the function, you just know the number and morphologic characteristics, what they look like, how we're going to identify them under the microscope, and then a little bit about thrombocytes and stuff like that. So certainly, the blood will be as part of the essay questions. But to be honest, just like the group problems, most of the essay questions would come from the cardiovascular section. And again, like always, group problems are a great place to start there.
Okay, cool. That was helpful. Thank you. And then as far as length, are you expecting like 10 points is equivalent to like 3 to 4 paragraphs, or a page, 2 pages?
Well, you can, maybe, fill in a table, right, or something like that, would suffice, or draw any picture, right? So as an example, if I asked you about the characteristics of blood, right, or compare and contrast the different formed elements in blood, right? So you go, okay, if I'm going to compare and contrast, my formed elements, what are they? Well, they're the cellular components of blood. So I need to talk about red blood cells, white blood cells, platelets. And the easiest way to do that might be to make a table, right, for a row for each one of those, and then a column for what they look like, how long do they last, what's their function, what other comments or something like that. So you could do that, or you could just write, like you said, sort of a paragraph about each one. So that might be a way to go for that. So it really depends on the individual question. And given that it's a take-home exam, I would expect more than less, right? And I would just expect you to write at the level of which we discussed that in class. So, I wouldn't give you an essay question probably where we only said 2 things about it. So, I would expect more detail, and you couldn't on an essay question, I wouldn't say, oh, you gave me too much, you know too much about this subject, I'm going to take points off, right? But I could easily say, oh, you know what, I expected more. And you know, I've got to take 2 points off because you forgot this portion or you forgot that or whatever. So you know, that was you know, Samantha earlier asked about the lab stuff and the lab reports. And that was, you know, probably the #1 comment I had is a lot of people talked a little bit about whatever they talked about, but didn't go into a lot of detail or didn't talk about other associated things. And you know, in my mind, some people didn't demonstrate they understood that whole thing enough to give them a good grade. So, you know, everybody got a pretty good grade. I don't think I've had very many in the 30s yet. I don't even know if I have any in the 30s. So everybody got between 40 and 50 so far in the lab reports, and I'm only about halfway done. But just think of it as you being able to show me you understand this enough to give you a good grade on it. All right. So, you know, as an example, let's look at the intrinsic and extrinsic factors, right? So in group problems, we had a whole question on each one of the factors that determine mean arterial pressure. So mean arterial pressure equals heart rate times stroke volume times TPR, total peripheral resistance. So you should understand the level that we went into each one of those. And partly the reason why I made each one of those factors a separate question is because I would expect potentially all that detail there if I asked you an essay question. And I thought about asking this question. I didn't, right? But this will kind of maybe um, answer sideways Alyssa's question that she put in the chat. I said, I was going to say, choose your favorite homeostatic regulator of mean arterial pressure and give me the intrinsic and extrinsic attributes for that and how it helps control mean arterial pressure. So if I ask that question, right, I wouldn't ask, you know, I think it's a lot to ask you everything for all 3 of those, right? But for one of them, just choose the one, and it didn't have to be your favorite, just the one you knew the best, right? And give me all the detail you could about that one question. And so, you know, certainly that's half the group problems, right? And so I would expect you to know the detail that we had for each one of those during the discussion. So, you know, for the intrinsic, for heart rate, it was just the SA node. The intrinsic for the stroke volume was the Frank-Starling law and preload and all the things that go on with that, and the difference between volume and pressure. And then for TPR, which is going to become important later because that's how I'm going to talk about the kidney again as a similar mechanism of how we control the filtration through the kidney, the myogenic mechanism, and the chemical hypothesis, right? So that's the intrinsic for each one, and I would expect, you know, sufficient detail for those if I were asking that, or if it was extrinsic, right? And here's the great thing about the extrinsic ones, to be honest. The extrinsic is always going to be sympathetic, right? And there's some role of parasympathetic in some of them, right? And so I think, you know, mentally, if we go heart rate, stroke volume, TPR, heart rate is both sympathetic and parasympathetic, right? Stroke volume is mostly sympathetic because there's few parasympathetic fibers that go to the ventricle that affect it. And then for TPR, it's only sympathetic because there's no parasympathetic fibers that go to blood vessels. So it plays a rest of the role, but you're always going to have sympathetic. And for hormones, all of the hormones, right, are going to be at least the sympathomimetics, right? So epinephrine and norepinephrine that basically support what the sympathetic system's doing. So if you know sympathetic, then you know at least one set of hormones. And for other ones, we had other hormones like the thyroid hormones that increase heart rate, and, you know, angiotensin and ADH and oxytocin that all help increase the all those things help increase the TPR as well. And then we also have the others, which make it more difficult. For others, like for heart rate was heat, right? Increased heat increased body temperature basically increases heart rate. The other things we could look at, the stroke volume had the most ones. It was calcium conductance and afterload and venous return all affect stroke volume. And then the nice thing for the TPR is, while there are things that could go under other, I figured we got enough already, so there were no others. So all of that detail involved with each one and how it affects it. And as an example, if you were talking about the parasympathetic influence on the heart rate, I would expect you to tell me about the variable effect of that based on the actual heart rate. So it has the most effect at below 100, and the sympathetic has the most effect above 120, and between 100 and 120, then it's about both. So depending on how the question was asked, I would expect a fairly complete answer, unless I said, well, just give me the major force, or pick one force and know that. Then obviously I wouldn't expect them all. And certainly all those things are important in the multiple choice, right? So like one we talked about in terms of resistance and Poseel's law would be of the factors that determine Poseel's law, which one has the greatest impact physiologically. And when you look at that, you go, okay, it's going to be the radius of the vessel for a couple reasons. One, we can actually control that minute to minute, second to second, literally, and it's raised to the fourth power. But the viscosity and the length, those don't change much, and they change slowly, and we don't control them. We control them for other reasons. So I would expect, the bottom line is, on any answer, I would expect you to know the level of detail we talked about in class to be able to answer a multiple choice question. And I would expect the level of detail that we talked about in class on any answer in an essay that you would do, especially on a take-home essay. Does that make sense?
Yes.
All right. What else? So Michelle, you never directly answered my question, because I got them done. I could release them earlier if you want.
Yeah, I'd love to work on it earlier, just because I don't
Okay.
know, it feels better to like get it done
All right.
early, and then if I finish it, then I can submit it early, but then I have also the option of submitting it but just before the due date.
Okay. All right. I'll make it available earlier.
Thank you.
Sure. What else? Anything?
That's all I have. I'm still reviewing my notes, so I may have questions for you later, but so far.
Okay. Yeah, maybe we'll do one of these for the lecture exam, like, I don't know, Friday, Saturday, something, as we get closer and people actually have had an opportunity to study those. In terms of blood type, absolutely should be able to do for lab, not lecture, but for lab, we talked about blood type. We didn't really talk about it in lecture at all. A Punnett square, right? So if mom was type AB and dad was type O, what are the possibilities the offspring would be? Or if mom is Rh negative and dad is Rh positive, what's the possible combinations for the offspring there? You should be able to figure out, probably more important clinically, so certainly more important for us, would be the transfusion. So who can get what transfusion, right? And what's the true universal donor? What's the true universal recipient? And things like that. So, what determines blood type? And, it's a glycoprotein on the surface of a red blood cell, as an example. And, we naturally produce antibodies against the type A, B that we don't have blood. But for the RH, we don't naturally do it until we get exposed to it for RH negative, as an example. So those differences as well for blood type. So yeah, you should be able to do one of those Punnett squares that we gave examples for.
And I would appreciate can do like a Zoom again, like on Friday or Saturday, like you said, because I am still reviewing the cardiovascular notes. So I probably have more questions later on.
Okay, yeah, we'll do one maybe in the afternoon or something on Friday or Saturday, or maybe both days. See what's going on. Maybe like a Friday, Sunday or something. Last minute questions on Sunday or something. All right. Any particular times or just whenever?
I'm whenever. I don't really have a particular time.
Okay. All right, maybe we'll do it like the afternoon, evening. I don't know, we did that one before the last exam. It was like what, 7 or 8 or something on Saturday or something. So, all right. Anything else?
I have a quick question about the hemolytic disease of the newborn.
Mm-hmm.
Is that only when mom has um, RH negative
Yes.
and okay, and fetus has RH positive,
Positive. Yes.
not the other way around.
Not the other way around.
Okay, thank you.
So just a quick explanation. Hemolytic disease of the newborn, what's called HDN, used to a long time ago be called erythroblastosis fetalis, is when an Rh negative mother has an Rh positive child. Okay, so that means dad genetically would have to be Rh positive, and he could either have 2 positive alleles, would be positive positive, or a positive negative allele. The likelihood of the baby being Rh positive is fairly high, even though mom's Rh negative, because remember, about 85 or 90% of the population is Rh positive. So there's a basically 9 out of 10 chance dad's going to be Rh positive. And then depending on what 2 alleles he has for the Rh factor, whether it's positive, positive, or positive, negative, there's a 50% chance if it's positive, negative, or 100% chance if it's positive, positive, fetus is going to be Rh positive. So there's a pretty good chance baby's going to be Rh positive. So when the first baby comes along, right? Usually, it's not always a problem because maternal blood and fetal blood don't mix except typically on delivery. And that's why they call it hemolytic disease of the newborn. It's when the placenta starts to tear away from the uterine wall during delivery where this mixing happens. So baby's blood, which is Rh positive, right, for the first baby, gets into mom's blood. And mom's blood says, oh, wait, this is a protein I haven't seen before. I need to make antibodies against it. Now, the antibodies mom makes is going to take a while, right? It's going to take a couple days. So the baby's already delivered and it's out and happy. And so the first baby's not an issue with that. But now the second baby comes along and it's Rh positive. And now when mom's blood and baby blood mixes, and mom's blood affected the baby not at all because there's no Rh negative doesn't have a protein that the baby recognizes as being foreign, right? So the second baby comes along and it's Rh positive again, and mom's blood and baby blood mixes this time. Now mom's blood has antibodies in it from the previous baby when she generated it that now basically attack the baby's Rh positive blood and starts to agglutinate it. So that's and destroy the blood cells and things like that. So that's why it's called hemolytic disease of the newborn. So the first baby's not a problem. It's the subsequent babies that happen. And so to fix that now, we have shots that we give mom that inactivates the antibodies so that during delivery, there's not that issue. So it used to be if you were an Rh negative female, you were considered a high-risk pregnancy because of that. And now it's a little more risky because some people have side effects from that and a few other issues. But I guess now the big issues are the same thing with ABO incompatibility. So if mom's type A blood and the baby's type B blood, you can have those issues as well, because now you naturally have antibodies against those. Baby wouldn't, but mom would. So, but that's hemolytic disease in newborn. So it's only an Rh negative mom with an Rh positive father. That's a good question because I almost had that as a multiple choice question. I said, what is the situation you need for hemolytic disease in newborn? And just gave listed, mom Rh negative or positive and dad Rh negative and positive, listed all combinations and asked which one. I took that one out, I think, I'm pretty sure. But so that was a good thought because I thought about asking that. All right, what else? Anything?
That's it for me at the moment.
All right. So if something comes up between now and tomorrow, right, email me, right, question. Make sure to, at some time before noon on Thursday, finish the lab quiz, right? I will try to finish grading the lab reports by the end of the week. And then we'll have at least one, if not two, of these more sessions that you can show up to, all right? All right, so we're good? Everyone, yeah? Looks like everyone's good?
Good.
Okay.
Thank you.
All right, so you guys have a good day, and we'll talk to you next time. I'm going to end this meeting, and we'll see you later.